Okay, in this presentation we are going to do a conditional probabilities exercise. Okay, so we'll just get straight into it because it's long enough, this one. A company obtains 2,000 components per week from supplier A, 2,000 components per week from supplier B, and 1,000 components per week from supplier C. Okay, quality control process show that 3% of the components from supplier A are defective. Likewise, 4% of the components from supplier B and 5% of the components from supplier C are defective. Okay, so given a lot to work with there. So there's two exercises that we have to do. Calculate the probability that a randomly selected chosen component is defective, and calculate the probability that a component is from supplier A given that it is not defective. Okay, that's a tough enough one. So we'll get our work cut out. Now, it's always a good idea just to actually state the events in a question. Just actually write them out like this. Okay, if you're doing an exam or something like this. So A is the event that the component is from supplier A. B is the event that the component is from supplier C. D is the event that the component is from supplier C. D is the event that the component is defective. And complement of D, or DC, is the event that a component is not defective. Okay, just spell them all out there. You notice that I do include the complement of D there because that's what we're asked in one of the questions. Okay, so let's look at the probabilities here. Probability of A is the randomly selected component coming from A, supplier A, was the probability of that. We know there are 5,000 components coming in. We're sort of told that in the question. We know that 2,000 come from A, 2,000 come from B, and 2,000 comes from C. So if we're selecting one at random, there's 2,000 of them from in there from A. So it's 2,000 divided by 5,000, which is 0.4. Likewise, 0.4 for company B, supplier B, and 0.2 for supplier C. Okay. Now the defect rates. What is the probability of a randomly selected component being defective given that it comes from supplier A? That is 0.03. Likewise, the probability of a randomly selected component being defective given that it comes from company B is 0.04. And C, probability of D given C defective given the supplier is C is 0.05. Just sort of take your time with those conditional probabilities, essentially. Just sort of get that clear in your head what a conditional probability is, the significance of being left and right of the bar, okay? Because that does actually help you a lot with conditional probabilities. We'll move on to the next slide. So we're going to get into the exercise now. Exercise 1, calculate the probability that a randomly chosen component is defective. Okay, so let's just say we have a big pile of components in front of us. Okay, and let's just say for argument's sake, we know which ones are which, what supplier comes from, which components come from which supplier. So let's just say for argument's sake, we have a big pile of defective components and we're able to sort them out into 3 piles, basically. That's an analog of that's a sort of comparison to what we're doing here. Basically, we can sort of split up the defective components into 3 parts. The ones that come from A, the ones that come from B, and the ones that come from C. So PD is probability of defective. That is equal to the probability of D intersection A, so defective and coming from supplier A, plus the probability of D intersection B, defective and coming from supplier B, plus the probability of D intersection C, defective and coming from supplier C. Okay, so what we can do is re-express that first equation using the conditional probability formula. So D intersection A, that becomes the probability of D given A times the probability of A. D intersection B, that becomes the probability of D given B times the probability of B. And finally, probability of D intersection C, that is probability of D given C times the probability of C. Now, we actually know all of those values. So essentially what we can do is just substitute the probabilities in that we have. So we have 0.03 times 0.4 plus 0.04 times 0.4 plus 0.05 times 0.2. That works out to be 0.012 plus 0.016 plus 0.01. And sum up the probabilities, so we get a probability D that is 0.038, 3.8% essentially. So the probability that a randomly chosen component is defective is 0.038 or 3.8%. Now, calculate the probability that a component is from supplier A given that it is not defective. Okay, so let's just write this out. Probability A given DC, complement of D. That is the probability that a component is from supplier A given that it is not defective. So what we're going to do here is use Bayes' theorem. Okay, so this is interesting. So probability of A given DC is equal to the probability of DC given A times the probability of A divided by the probability of DC. Now we know the probability of A and we know the probability of DC. Okay, so we know that the probability of D is 0.038, so the probability of DC is 0.962. Likewise, probability of A is 40%. So what we have to do here is find out the probability of DC given A. Okay, now that is 1 minus the probability of D given A. Okay, so it's what is the probability that they're not defective given that they come from A? So essentially this is a straightforward complement of information that we are given. It's essentially just verbalizing, figuring out in your head, rationalizing in your head, what proportion of them are okay given that they come from A? Well, if we know that 3% are not okay, that means 97% are. So it looks a little bit trickier than it actually is. Just to actually sort of try and keep yourself grounded in the reality of this scenario. Okay, I know it's hypothetical and an exam question, but just try and sort of, when you're looking at these sort of formulas, just actually sort of try and rationalize them in terms of something practical. Anyway, cut a long story short, it is 97%, 0.97. So probability of A given DC is 0.97 times 0.4 divided by 0.962. So using the calculate the numerator is 0.388 and divide by the denominator 0.962 and we get 0.403. Okay, so the probability that a component is from supplier A given that it is not defective is approximately 0.403 or 40.3%. Okay, that's good. We'll leave it there.